That I think the history of population growth and then abandonment has a lot of similarities to what we've seen in the 20th century, the Dust Bowl. And maybe we may have, in the development of the Southwest in recent decades, happened also during a very wet period. So now, just to finish up, we have the future. This is actually the precipitation time series averaged over the U.S. Southwest from a model run that was conducted by the Geophysical Fluid Dynamics Laboratory of NOAA down in Princeton, and I've strung together their historical simulation from 1860 with their future simulations out to 2200. So in the 19th century and 20th century, the model gets sort of the same kind of variability that we see, every now and then a serious drought. But beginning right about, there were 3 of these runs for the 20th century. That's why there are 3 plots here. They only did 1 for the future out here, so that part of the diagram is the same on each one. But beginning right around now, in this model, the American Southwest goes off to a perpetual drought from which it never, ever, ever recovers. And although Wally said that models tend not to agree on regional features like this, it turns out that the models do agree on this. And they agree on many things like this. Each line here is there are 19 different models that we used in the IPCC scenarios. The one I just showed you was one CM 2.1. It's one of that one, right? It's down here. British models, some of these are Japanese models. They're everyone from all over the world. And this is the change in precipitation minus evaporation. So it's the supply of moisture from the ocean to the land. And it's also equal to the runoff over the land, averaged over the Southwest for these decades, 2000 to 2020, 2020 to 2040, out to 2080 to 2100, minus what the model thinks the climatology is for 1950 to 2000. And you can see that 0 is here. They're all on the negative side, with the exception of just one model, which... Anyway, the majority of these, about 3/4 of these models, indicates a significant drying. Now, my estimate of where the Dust Bowl P minus precipitation minus evaporation anomaly is about here, sort of just under 0.1 millimeters a day. So these models are generally agreeing that within the next few decades, Dust Bowl severity drought is going to be the new climatology of the American Southwest. And it's happening right now. Even within this decade, most of these models are on the dry side. We're already almost halfway through this period. But out here, which is only a decade or just over a decade into the future, this is already established. So this is a map of what the precipitation minus evaporation change is in this GFDL model for 2021 to 2040 minus 1950 to 2000. There's the drying over the Southwest, but it's fitting into a global pattern. The Mediterranean region, Mid-East, Central Asia, North Africa actually gets hit even harder by this drying. But it's a general feature of the subtropical drying, moistening at higher latitudes, something like this in the southern hemisphere as well. Wally referred to the Isaac Helms mechanism for explaining that, and he said it's a consequence of rising atmospheric moisture. That's actually not the case, because over land you have to have atmospheric moisture convergence to sustain precipitation, because you don't have an infinite supply of moisture at the surface. So just increasing the humidity in the atmosphere because the atmosphere warms up, you would expect precipitation over land to increase. And it does in some places, but in other places it does not. If precipitation decreases over land, you have to have reduced atmospheric moisture convergence, and that can only come about through a change in the atmospheric circulation. And so that's what's happening over the land regions, and what we think is going on is that there is in the warmer world, there is a general shift in the climate circulation regimes poleward. So the Hadley cell overturning in the tropics, which starts near the equator and descends in mid-latitude, extends poleward, so the descent extends poleward, and that the storm tracks and jet stream in the mid-latitudes also shift poleward as well. So the rain-bearing westerlies move poleward. And this, you can get this fairly easily in a model just by warming up the surface of the ocean, the surface of the planet uniformly. Okay, so where on this trajectory are we right now? We have had this drought that's been going on from 1998, since 1998. During this period, where is it again? During the period from 1998, during the period from 1998 to 2002, there was a persistent La Nina. And so that part of the drought looked very much like the previous ones. But the drought persisted, and it carried on after 2002 when a weak El Nino developed, and we've had a weak El Ninos, weak La Ninas since then. And this shows you what happened in Lake Powell. This is the level of Lake Powell, September 1999. It reached a low sometime at the end of 2004, early 2005. This is where the water pipes are that go into the power generation plant. So it was getting dangerously low to where it wouldn't be able to be used to generate power anymore. It had never been this low any time since the dam started filling up in